This experiment is to observe the relationship between the pressure and the temperature for the saturated steam. The apparatus used for this experiment is Marset Polar. Marset Polar is used for the understanding of basic properties of saturated steam. The experiment starts with boiling the water at the room temperature until the temperature reached approximately 97 to 100 degree. The temperature increasing and the temperature decreasing is recorded for every 0.5 bar pressure until the pressure is 5 bar. As the result, the temperature increases as the pressure increases. At a certain point, some of the values are not the same. This is due to some errors occur along the experiment. The Masset boiler is the unit of demonstration of the basic principle in the thermodynamic studies. Initially, the discovering of this phenomenon is founded by Rudolf Clausius, a German physicist that was a thermodynamic power icon. It is used to test the relationship between pressure and temperature for saturated system. It consists of a high-pressure electrical heater, safety valve, thermometer, and pressure gauge. Thermodynamics deals with the interchange of energy such as heat and work between system and the surrounded, which occurs when the system undergoes a process heating or cooling. The loss of gain of energy in a system has a direct impact on thermodynamics properties. Generally, water molecule will become more active after having an increase in energy. This is cases the the molecules to leave the sectors of the liquid and until equilibrium states can be achieved. The temperature where the equilibrium is achieved at a certain given pressure is called the saturation temperature.
Assalamu alaikum everyone. My name is Ahmad Sabri Rajab. I'm from Group 3. Today we will be present about our experiment 1, which is the market boiler. I will be talk about the part of the methodology, and to start with my part, we should know our apparatus and our equipment for this experiment. So the first one, which is master switch, heater switch, and the temperature reader. Also, we have the pressure gauge and failure block and overflow valve. So this is the shape of the pressure gauge, and this is the failure block, overflow valve, and the temperature reader here, and the master switch here, and the heater switch there. Okay, so I have put some points for our methodology. The first point, which is for the water, was filled into the boiler by opening the water filling plug, and the valve overflow was make sure opened and let the water flowing out from there when the boiler was full. The second thing, which is once the water was flowing through the overflow valve, stop the filling and close the filler plug. Also, tint it is using the spinner. So for the third point, which is the main switch and the green heater switch were turned on and wait until the temperature reach approximately 97 Celsius to 100 Celsius. The valve overflow is closed when the temperature reached about 97 Celsius to 100 Celsius. The fifth point, which is the temperature of every 0.5 bar pressure increasing is recorded until the pressure is 5 bar. For the last point, which is heating switch was off and the temperature decreasing for every 0.5 bar pressure decreased was recorded.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Adalil Kumar Biasali. I'm from Group 2. I'm from Group 3. Today I will present the result from my boiler experiment. This is the result for what we get from the calculation and the experiment, which is calculation absolute pressure, increasing temperature, decreasing temperature, means from the two temperature, measure slope, calculate slope, and percentage error. This is a sample calculation for absolute pressure, how we calculate for absolute pressure, how we calculate the dP, how we calculate temperature, mean temperature, calculate dT, and how our group calculate for measure slope. This graph represent the pressure versus temperature for heating and cooling process and determine the slope of the graph. For the first graph, for heating process, the relationship between absolute pressure and saturated steam temperature for heating process is displayed in graph 1. We can deduce from the fact that absolute pressure increase as temperature increase. For the next graph, represent the decreasing cooling process. For the cooling process, graph to show the relationship between absolute pressure and saturated steam pressure. Even the heating switch was switched off, the temperature continued to rise during the cooling process. The graph also shows the temperature increase when pressure increase. Next graph represent the absolute pressure versus mean temperature. For this data, show the calculate the value of calculate slope using saturated and steam, and compare with slope graph as show you obtain. For the sample calculation, how our group calculate for the calculated slope. For the next table show the percentage error. This is the sample how our group calculate for the percentage error for this experiment. We can see that there is a disparity between observed and calculated slope in the table above. The percentage error value indicate that an error occur during experiment resulting in value deviation. That's all from us for result from the experiment. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nuratika Syahira binti Uyub. I will explain about the discussion part. For the discussion part, I need to discuss about the observation during the experimental conducted, and also discuss the plotted graph and indicates the relationship between the temperature and pressure of steam. For the first discussion, I need to discuss about the two curve graph were plotted for both heating and cooling process. The readings show that the pressure before the experiment and temperature of water was at room temperature before the experiment started. And it also, when the experiment started, pressure increased as temperature increased. From that, this is due to relationship between pressure and temperature, and it can be explained by the relationship between temperature and pressure. For the next discussion, for both graph 1 and graph 2, the form of curve that we have were quite similar because the decreasing rate of temperature during the cooling process. is about the same as increasing rate of temperature during the heating process. However, cooling process needed more time as water cooling slower than heating it up. From that, this is because we let the water cool at room temperature, which does not have any catalyst or instrument to let it cool quickly. That's all from me. Thank you.
In conclusion, the thermodynamic properties of a boiler substance could be determined by the two of the following characteristics, namely temperature, pressure, entropy value. So the temperature and pressure are two of the properties which easily determined by experiment. After studying the result and plotting the diagram, we find out that the relationship between pressure and the temperature is directly proportional.